Welcome to our farm. We're proud to show you how we raise the healthiest pigs for our premium pork sausage.
Reports track 42 clear.
Confirmed. Barcode scanned and logged.
We have an anomaly detected on the current run.
Noted. Adjusting the parameters now.
We're running slightly high on the yield here.
Yeah, I saw that. Adjusting the blade speed now.
The trimming yield is up by 2% this quarter.
Yes, the K5 units are exceeding projections.
Check the throughput on line 3.
Reading 82.5, well within tolerance.
We have a variance on line 3. Adjust the flow rate.
Done. Weights are back within tolerance. The flow rate on the KL45 line seems high.
It's within tolerance. The system compensated for the weight differential 2 seconds ago.
The density on sector 4 seems slightly elevated.
Yes, but it's within the acceptable tolerance range for this batch. The alignment on these cuts is exceeding the target metrics.
Yes, the new sequence optimization is working better than expected. The fat to lean ratio on line 3 is holding steady at 90%.
Good, the calibration is perfect.
Core temperature holding at 3 Celsius.
Acknowledged. Logging the cycle data now.
We are seeing a consistent density reading here, which indicates the sensors are perfectly calibrated for this cut.
Excellent. The throughput is optimal.
The alignment seems consistent.
Yes, the calibration held steady since the last cycle.
Look at the consistency of the cuts right there.
Yes, the calibration is perfect since the update.
The flow rate is holding steady at 2.8.
Good. Let's maintain that consistency through the next cycle.
The auger rhythm is steady, no blockage near the shield.
Good. Let's keep monitoring the transparency here.
Check the pressure on line 3.
Looks stable at 200 psi. Check the flow rate on gauge 3.
Looks stable. Logging the data now.
Good. Pressure looks consistent across the line.
Check the pressure on line 3. It seems stable now.
Yes, the flow rate is optimal. I've logged the data.
Sensor calibration is stable at 2 degrees Celsius.
Confirmed. Data logs match the thermal profile.
The viscosity is reading slightly high on sector 4.
Adjusting the flow rate now, standard deviation is normalizing.
The sensors show the blend stabilizing right on schedule. Look at the readout here.
Yes, the thermal curve is perfect. I'll update the manifest.
The flow rate on loop 3 looks stable.
Yes, viscosity is holding steady at the target temperature.
Here are the latest blend metrics.
Looks consistent with the target range. Good work. Flow rate and consistency are within tolerance.
Confirmed. Logging the results now.
Check the viscosity levels here.
Confirmed. Everything is within tolerance.
Note the blend uniformity at this speed.
Recording it now. Looks excellent.
Check the pressure reading on panel 4. Right, logging that now. Everything seems optimal.
What's the flow rate on the homogenizer?
It's steady. Check the main panel readings. The indicators are fluctuating slightly.
It's within tolerance.
The mixture looks stable now.
The internal temperature is holding steady at the target range.
Good, I'll log that on the QA report.
Check the vacuum pressure on line 3.
Holding steady at 25. Temperature is optimal.
The texture profile seems consistent with the baseline.
Yes, the elasticity is perfect.
The pressure in loop 3 looks stable. Yeah, flow rate is optimal. We should check the casing alignment next.
Reading 25 psi on the torque. Acceptable deviation.
The blend density is accurate.
Noted.
The flow rate is holding steady at 250 liter per minute.
Confirmed. Pressure looks stable across the manifold.
We need to increase the flow rate slightly.
Adjusting arm 2 now. Casing consistency is stable.
The current reading is holding steady at 5600K.
Acknowledged. Finalizing the adjustment now. Looks good.
We need to monitor the alignment right here before the casing stage.
Agreed. The synchronization is critical at this junction.
Temperature holding steady at 2 degrees Celsius.
Optimal consistency achieved. Pressure stable at 200 psi.
Confirmed. Blend ratio is holding steady. Right there. See the consistency? Frequencies?
Yes, the meter confirms it. Looks good. Let's proceed.
The segmentation rate is holding steady at 98%.
Good. Let's monitor the valve pressure on line 3.
The stability metrics are holding steady at 98%.
Noted. The blend density is confirmed. We can finalize the report.
Pressure looks stable at 2.8 bar.
Confirmed. Flow rate is optimal.
Check the pressure on manifold 3. We need to maintain the flow rate.
Confirmed. Viscosity levels are optimized. Looks good.
Check the primary gauge on line 3. Reading steady. Synchronization is optimal.
Warm-up sequence is complete.
Alignment looks good across all axes. We are ready for production.
All sensor data is green. Viscosity confirmed.
Looks good. Ready for automated casing.
Pressure spike on line 3. See that?
Yeah. Compensating now. It's holding steady.
Perfect. The calibration looks accurate. See the display there?
Yes. Reading confirmed. Everything is within specifications.
How are the twists looking on the run?
Well within tolerance. Confirmed by the sensor array.
The run is looking exceptionally clean today.
Yes, the calibration on the new hangers is perfect.
The internal temp on rack 3 is stable.
Copy that. Sequence is running perfectly.
Set the temperature profile to 75 Celsius for the initial phase.
Confirmed. Adjusting the cycle time now. Looks good.
The delta on the 1500 line is stabilizing nicely.
Yes, we're well within the safety parameters now. Data confirms the adjustment.
The color looks consistent on this batch.
Agreed. Temperature seems stable as well.
All right, steady now. Gates opening.
Wait.
Clear. Pushing it in. The smoke curve is steady now. Bring the airflow down by 5%.
Confirmed. Density levels are returning to target range.
The color saturation is spot on with the reference swatch.
Yes, the golden surface developed perfectly.
The airflow on the lower racks looks inconsistent.
I just calibrated the left baffle. It should stabilize.
We need 80% humidity for the pork. It's reading 78 right now.
Okay, let's bump it up 2 points on the main control.
The ACF profile looks accurate at 5600K.
Agreed, the mahogany is spot on according to the tone charts.
The rotation cycle is holding steady at the optimal temperature.
Yes, the consistency on rack 4 looks perfect.
Core temperature holding steady.
Thermal imaging confirms integrity.
We are clear.
The internal core rise here exceeds the threshold.
It aligns with the historical data on the monitor, though.
All right, the trend is acceptable for the batch.
The surface sheen here is excellent, very consistent with the golden standard.
Agreed. The smoke deposition looks perfect.
We're clear for the next batch.
Confirmed. System running smooth. Reading steady at -20. How's the flow rate?
Flow rate is optimal. We are clear for phase 2.
The temperature on probe 12 is stabilizing.
Confirmed. We are clear to advance the cooling cycle.
Definitely within the acceptable reddish-brown range.
Yes,
Right.
yes, it matches the standard exactly.
The humidity level is holding steady at 82%.
Confirmed. The stabilization cycle is proceeding as expected.
Pressure looks good on clamp 4.
Yes, the temperature is stable. I'll log it now.
The internal temperature is holding steady at 34 degrees.
Good. The seals on the new chamber are working perfectly. Temperature holding steady at -20.
Verified. We are clear to load the first rack.
Check the thermal regulator on Unit 3.
Reading confirmed. Status ladder is green across the board. Ready for loading.
The stability here seems slightly off, almost brittle.
Noted. Thermal reading is steady at -2.
Keep an eye on the blade speed here.
All right, I'm monitoring the readout now.
The variance on Unit 3 is holding steady.
Good. Let's run the calibration sequence now.
Looks good to go.
Approved for transfer.
Right here, see the abrasion on this one.
Yes, noted. We should pull this batch.
Okay, pressure stabilizing at 850 millibar.
Looks good. We are within tolerance. Let's proceed to the next batch.
Peak force recorded at 55.2 newtons.
Adhesive failure, top right quadrant.
Watch the alignment on that last batch, Sarah.
Looks stable, sir. Running at full capacity.
Expiry date verified and placement is correct.
Confirmed on the manifest. Moving to approved.
Check the seal right here, Barb.
Looks clear to me. No hazing. Passes inspection.
We have a slight misalignment on the third arm.
Noted. It's within tolerance, but keep monitoring.
Cycle complete. Moving to batch B. Everything looks good down here. We're on schedule for the pork shipment.
Good. The data matches up.
The alignment on the Z-axis looks stable now.
Good. We are maintaining the target throughput. How's the cushioning on the bottom layer?
Secure. The fit is perfect.
We're maintaining optimal speed and temperature here.
Yes, the adjustments seem to have corrected the sealing issue.
Labels checked and verified.
All right, send it through.
The throughput on line 3 is exceeding projections by 10%.
That explains the bottleneck near the stacker.
The alignment on that last row was perfect.
Yes, the throughput is exceeding the projected metrics. Check the bottom layer, make sure it's secure. Looks solid. We're good to go.
That stack looks good. Make sure the wrap is tight.
Confirmed. We can load this one now.
Final pallet loaded. Bay 3. Secure the shipment.
Copy that. Retracting. Over.
This one has the lowest sodium.
Is it healthy?
It's a good choice. Let's get it.
What do you think of this brand here?
This is the one Ken recommended. The ingredients look fine.
All right, let's grab 2 packs then.
Here are those sausages for you. Did you find everything okay?
Yes, I did. Thank you.
Have a great day.
Got everything we need.
Are we having the hot dogs or the sausages today?
We got both, buddy.
Look at these sausages. They look incredible. They smell amazing, honey. Pass them down here. I can't wait to try one.
This sausage is really good.
I told him we'd need seconds.
To the best sausages in America. Cheers.
Get those sausages while they're hot. They look amazing, thanks.
Cheers, everyone. This is great.